Welcome to my GIS lab. Here I will show you how to display rasters, especially elevation models, and how to convert a feature file to a raster file. Like many tools in a GIS, they are simple to execute, but it takes planning, thinking, and understanding of the controls to get the results you need. I have here a raster file called FHDM10. FH stands for foothills and digital elevation model 10 meters. We know it's 10 meters if we go to the attribute table and under raster information, first of all, vertical units are also in meters. Raster information is here. Cell size X direction is 10 meters. And Y is also 10 meters. And we know that it's meters because if we look at the spatial reference information, we have here a regular UTM-based projection, which is in meters. So meters is confirmed. And the one other thing here that I forgot to show you is that we also know how many rows and columns we have. So this is a pretty detailed file altogether. Before we go any further, it's always important to understand how we can visualize the raster in the most meaningful way. If we simply click here on our stretch color scheme, the default when you open up a new raster file or image is typically gray, and here of course we have a long list. And if you hover over any of these, then you can see that they have names. Elevation 1, elevation 10, elevation 11. And so the elevation ones are the ones we would like to use. And so here is the default setting right now, and you have to pick the one that you like the most. So there's a whole wide range, and it is person preference. I personally prefer this one over here the most. After you've selected your color scheme, the next thing you should be in control of is, do you want to use the full range of the color scheme or maybe just a part of that? The default stretch is minimum to maximum, which means the minimum value that we find in our raster file is assigned one end of the color spectrum, and the maximum value is assigned to the other end of the spectrum. And between those two extremes, and we have a linear stretch between minimum and maximum. We can see this when we click on the histogram. Here's our min value, our max value. We have a linear stretch here. And here in this histogram, you see that there's a lot of green, a lot of colors at this end here, and very, very few white or very light gray colors here. So that shows you simply how often certain colors are used in the current raster display. As we are in the foothills, I don't want to display the top of the ridges in gray because it's neither bare rock nor is it glaciers. So I want to use more the brown colors. So what I can do here is I can control the range of values that is used by simply going to custom, and now the min and max values are editable. And now I want to assign a higher elevation value here, a value that does not exist in our raster file, but assign it here so that we just have a different kind of linear stretch. Let's assign it the 2300. And we see now that the gray areas here have disappeared. There is a bit of a shift. Look, if I go back and forth between the two, you see here is one option. Here's the other one. I like this better, and I could do the same thing by now assigning a lower of the lowest elevation values here, and then I would assign that lower value to my bluish color, and that means the bluish color would not be displayed in the raster as it is here right now, and instead it would be maybe a green or a light yellow. So now that we have control of our color scheme, when we display raster files that are digital elevation models, I really encourage you to always turn on and create a hillshade. A hillshade is created within our toolbox, and near the bottom of the toolboxes there's a spatial analyst tools. Those are our raster tools. You would find here, for instance, hydrology tools, you find distance tools, map algebra, the raster calculator is available. And here at the bottom we have also some very important tools, solar radiation tool, I'll discuss it in my 4th year class, and then our surface tools. And within the surface tools, this is where you can create your hillshade. The hillshade means simply that you put the sun into a certain location and basically turn on the light and then simply displays what is shaded. The default values is that we have an azimuth, so a direction relative to north, where north is 0 or 360 degrees. So right now azimuth is 315, so that means we basically put the sun into the northeast. Altitude of 45 degrees is good because it creates good shade. If you make it too steep, that means a high value up to close to 90 degrees, then it's like having the sun right above your head and there's very little shadow. And if you make the sun too low, then you have very long shadows, and that also doesn't help to understand the terrain very well. One important factor that you should always consider with hillshades is that we can do a vertical exaggeration of our elevation values. Because we are in a relatively flat terrain, I like, just for the hillshade, to exaggerate my elevations 5 times so that the details of the foothills topography become better visible. And in my case, I simply want to rename this. And I hit run. And here's my hillshade perfectly overlaying the DM, except at the very, very edges. We get to that later. So again, the default display is in gray, which works for the hillshade display. So we have a nice feeling for the terrain now. And if we make the hillshade, we make this now about 50% transparent. Now we see both the hillshade and the elevation model, and you will agree that the elevation model with a hillshade comes much more to life, is much more meaningful, it's much more better to understand and get a feel for the terrain than otherwise. Again, with hillshade and without. But you may wonder, why are we putting our light source for the hillshade into the northwest? Why don't we put it somewhere in the south, where the sun naturally would be? Let's try that. So 315 minus 180 degrees is 135. So now we're positioning the light source into the southeast. And let me change my name here, southeast. And let's run this. And the result may not be what you expected. It looks as if the river is running and meandering along the top of a ridge. And it looks as if here we have deep incised valleys that are oddly shaped in a way. Valleys don't look like that. So comparing this to other hillshade, you see that basically the two are inverted, simply by putting the light source into opposite positions. Here's a case where the default value of 315 and an altitude of 45 degrees work excellently. I recommend you do not play with these. The only thing you want to do is, if you have flat terrain, you may want to use a large Z factor. So now we have our elevation model. We understand the range of our values. We applied a color scheme that we enjoy. And we now also draped a hillshade over the elevation model to give it a visual, much more stunning appearance. I have here added a shapefile representing my rivers. The attribute table contains a field called layer, which defines the type of river I have, such as permanent stream or oxbow lake. I want to convert this line shapefile to a raster in such a way that I can later overlay it with my digital elevation model. To convert, I go to Toolboxes, then Conversion Tools, and within this toolbox I go to To Raster, and within here I choose Polyline to Raster. It is very important to understand the environment settings, as they control how your resulting raster will be created. If you apply the environmental settings here within the tool, then these settings are only used for this particular tool. But if you apply the environmental settings over here under the analysis ribbon, then these settings are universally used for all the tools in this entire project. These settings are remembered if you save your project. I want to focus here on 4 important environmental settings that are specific to raster analysis, and these are the spatial extent, the snap raster, the cell size, and the mask. Right now, the only parameter I want to change is the cell size, and the best way to control this is by selecting the cell size from an existing raster file. That way you will ensure that the cell sizes are identical. In my case here, I will choose my 10-meter elevation model. I could also use the hillshade. They are identical in cell arrangement. We keep all the other default values right now, and we hit OK. The input file is my river file. The value field is this layer that I want to maintain in my raster file. And if you prefer to not use the default TIFF file format, you can simply delete the extension, and now you could, for instance, use a generic Esri file format. However, the raster file format in grid format, in the original Esri format, is restricted to only 13 characters. So this file name here would be too long. If we were to accept this, then we get here a warning message that the length of the grid must not exceed 13 characters. And if we go back to add the TIFF extension again, then TIFF allows longer file names. So maybe TIFF is the better format here. We see that the cell size has already been set to our 10-meter elevation model. That's great. We accept the rest of the default settings and hit Run. Here you see the TIFF raster file. You can see that the values inside the raster cells have been adopted from the layer attribute. So where is our raster file? We can't really see it. Well, let's zoom in into an area. And if we zoom in enough, because our raster cell size is quite fine, it's 10 meters by 10 meters, here is our resulting converted river file into a raster file. So what are the values that are not rivers? So let me turn off the other layers right now and simply query, for instance, inside my raster file, I have here my correct cell value. And anywhere where it's white at the moment, there I have no data. And what we can do is we can actually visualize no data by going to Symbology, right-click, Symbology, and under Mask, right now no data is set to nothing, so let's just use another color. Let's use yellow here, and here now we can see the map extent of our river file. Why this map extent? What happens internally is that along the top and the left edges of the new raster file, they follow the furthest extent we have for the river file. So let me turn on the river file again. And here you see this is the very western edge of my river file, which was clipped to this extent originally. And the same thing here along the northern edge, we will find a river that is going right up to the very, very top, which is over here in our case. The other two edges, the eastern and the southern edge, they both add a raster where it's necessary, because the river file ended here, but simply to make sure that we are within our 10-meter increments, here we have added this last grid cell at the eastern edge, and also the same thing for the southern edge, just to make sure that the rasters are all 10 by 10 meters. I make my no data invisible again. And I want to zoom back into any area here. And if we zoom deep enough, then we'll recognize that the position of our 10 by 10 meter grid cells does not match that of the elevation model or the hillshade. We can control that. We can control that by going back to our environment settings and now choosing a snap raster. A snap raster is an existing raster file, in our case, of course, our 10-meter elevation model. And if we turn snap raster on, then the newly created raster file will snap to the spatial extent of all existing cells. That is something that we would like to do. So let's see what happens if we hit OK. I'm creating a new output file. I leave everything else in place. I hit run. And here now we see randomly assigned new colors. Here is our new raster file, and we can clearly see that this new raster file, in this case here, matches perfectly the elevation model rasters. So that is something that you have to consider, is the snap raster. Now let's see how we can control the spatial extent of our raster file. I have here a shapefile with a watershed, and I would like that all new created rasters fit the extent of this watershed. So we can control this again in our environment settings by choosing the extent of an existing file, in this case our watersheds. Again, I keep everything else the same. I again rename my raster output file, and I hit run again. And now if you zoom in, the spatial extent of the raster file has changed from number 3 here. Let me turn back on number 2 that we had. We see that number 2 had a wider spatial extent, and now our spatial extent, as before, follows the very western, northern, eastern, and southern edges of, in this case, our watershed file, but it still bleeds out outside our watershed, and we don't want that. We want these river files to be non-existent. So we can go further and set one more and last environmental setting, and that is using the mask. So now I'm using to mask out everything that is inside our watershed 1 shapefile. And let's create a fourth output. And now the resulting rasterized rivers are clipped to our mask, our watershed file. We can see that the number of layers has also been restricted because we only find 3 types within this watershed. This was the last one, and this was the one without the mask, and we see now it's basically been simply clipped automatically to my study area. So with these environmental settings here now, we have enforced that the newly created raster file matches spatially perfectly the grid cell size and the grid cell positions of existing raster files, and we can control the extent and the mask of the resulting raster file. Please remember these options when you do a conversion from feature to raster. Another way how we can use this mask setting is, for instance, clipping existing raster files. Let me quickly demonstrate. If I go to the raster calculator and I choose my elevation model and I give it a new name, and I simply say input file elevation model, output file new elevation model, now it will use my environmental settings to clip the raster file. And here you see how I simply clipped my elevation model. Let's use the default settings right now for argument's sake and turn off my original one. And now we can appreciate how the mask works. So please remember the importance of setting your environmental parameters for your project. Remember, once you set them, they apply for all the tools inside the toolboxes, everything in here. And if something doesn't appear how you want it to be, then probably because your environmental settings were wrong. That's all for today. Until next time.